Hello students. In this video, we'll be discussing a few questions about the pH from simple to most advanced ones. So let's start with the first question. What is the pH of a 10 raised to minus 7 molar solution of HCl? Now, what is the formula of pH? The formula is negative log of H plus concentration. Now we are provided with the H plus concentration, that is 10 raised to minus 7 molar. So we'll just put that value into the equation, and by simplifying it, we'll get the pH, that is in this case 7. So the answer of this question is option 3, pH 7. Now on to the second question. The pH of endocytic vesicles is 5.2 and the pH of gastric juice is 2. Now the endocytic vesicle has a H plus ion concentration, that is, and our options are: first, 15.85 times lower than that of gastric juice. Second option is 0.1585 times lower than that of gastric juice. Third option is 158.5 times lower than that of gastric juice. And fourth option is 1585 times lower than that of gastric juice. Now, how will you get to the right answer? This is the formula for pH, that is on the log scale. Now, log scale means that the difference of one unit is equal to 10 times difference in the actual values, which means that H plus ion concentration at pH 2 will be 1000 times higher than H plus ion concentration at pH 5. And because the pH is the negative log, that means higher the H plus ion concentration, lower will be the value of pH, and higher the value of pH, the H plus ion concentration will be lower. So now from these calculations, we don't even need to get the exact number. Any number that is in the scale of 1000 will be our answer, which is in this case option 4. Now see, if you know the formula, then you don't have to do all the calculations, and sometimes you can take little shortcuts. Now, if they really wanted to test you, they could have given all the answers in the all the options in the same range, like in the scale of 1000, and then we'll have to do the actual calculation. But since they have not, so we'll just take this shortcut. Now, on to our third and most complicated question out of all the three. So the question is, gastric juice, which has a pH of 1.5, is produced by pumping HCl from blood plasma, that has pH of 7.4, into the stomach. Now calculate the amount of free energy required for hydrogen ion transport to produce 1 liter of gastric juice at 37 degrees Celsius. Now, how many moles of ATP must be hydrolyzed to provide this amount of energy? The free energy change for ATP hydrolysis under cellular conditions is about minus 58 kilojoules per mole. And the value of R, that is gas constant, is 8.315 joules per mole per Kelvin. Now, the transport of H plus against the concentration gradient, that is from the blood plasma to the gastric juice, is a process of active transport. And for active transport, the free energy change will always be positive, because the energy is required to transport the ions against their concentration gradient. Now the formula for this free energy change will be uh, free energy change delta G equals to RT ln C2 by C1. Now here R is the gas constant which is already given in the question. T is temperature in the Kelvin. Now we are provided temperature in the 37 Celsius. So we'll convert it into Kelvin and we'll get 310. Now ln is the natural log and C2 and C1 are the hydrogen ion concentrations of gastric juice and plasma respectively. So this means that first we'll need the hydrogen ion concentrations of gastric juice as well as the blood plasma. So we'll just get both of them from the equation of pH for gastric juice. The concentration of H plus ions will be 3.1 into 10 raised to minus 2 molar. And the H plus ion concentration for the plasma will be 3.9 into 10 raised to minus 8. Now we have all the four values required for the free energy change calculation, and we'll put them into the equation, and from solving this we'll get the free energy change to be around 35 kilojoule per mole. Now since we are given in the question the free energy of hydrolysis of ATP which is 58 kilojoules per mole, and the energy which is required for the transport process is 35 kilojoules per mole. So from these two numbers we can calculate the moles of ATP required to provide the required energy for active transport, which will come to around 0.59 moles. Now coming back to the question and looking at the options. Option 1 is 34 to 36 kilojoules per mole and zero point 0.6 to 0.61 mole. Option 2 is 3.4 to 3.6 kilojoule per mole and 6 to 6.1 mole. Option 3 is 22 to 23 kilojoule per mole and 0.3 to 0.31 mole. And option 4 is 70 to 18 kilojoule per mole and 3 to 3.1 mole. Now from the calculations that we just did, the correct answer is option 1. That is 34 to 36 kilojoules per mole and zero point 0.6 to 0.61 mole. As you can see in this question, we have used the concepts of both pH and also the free energy concepts that we used in the videos of enzyme. Keep coming back to my channel for more such videos. Right now we are focused mainly on the first unit of the CSIR syllabus, that is biomolecules. And after finishing that unit, we'll move on to the second unit, that is cellular organization. The CSIR exams will be most likely held in the June. So my target is to finish the syllabus by June. So you guys have a proper tools for revision. Thank you for watching my video.